In the last chapter, we looked at extrusion. And as we saw, extrusion is quite a simple process. We take a shape, we move it along its z-axis, and we interpolate that movement and we create polygons from that interpolation. And this gives us an object with depth. It takes a very simple 2D shape and turns it into a three-dimensional shape. With a loft, we do a similar thing, except that instead of just translating in a straight line, we rotate the shape through 3D space. And again, we interpolate as we do that rotation, and that gives us a three-dimensional form. As with extrusion, lathing is a real-world process that is used in many manufacturing processes. With a lathe, a block of material is clamped between two sharp points that lie on a central single axis. Burrs around these points then bite into the material and give that central core of the lathe some purchase on the block. Then what happens is the central core of the lathe spins, and that then spins the material, the block of material, which is held between the two end points. It spins that block at high speed, and it usually rotates at a very, very high speed. Then what happens is a tool, a bit, is applied to that block of material as it rotates, and it bites into the surface of that material. Because it's rotating, it then cuts out a groove in the surface all the way around the block of material. Very often, that block of material may actually start off as a cylinder, but by the end of the process, it will always end up as a cylinder because basically, as it gets rotated, the tool bites into the surface and it cuts away the surface and will always produce a cylindrical shape of one type or another. So, as I said, as the material is gouged out, the block is formed into a cylindrical shape of a certain diameter, and that diameter is based on the distance of the bit away from the actual central axis of the lathe at each point. That distance and position along the block is based upon the input of the person using the lathe, or today it's more commonly controlled by a computer in most industrial lathes. Industrial lathes are very large and very, very expensive, and they're also incredibly precise. And they can actually lathe a block of metal down to, microns, very, very small distances. And that allows some of the machinery that we have today, it allows us to have very precise engineering. Of course, there are limitations to the lathe. The material can't be brittle. When pressure is applied onto the block of material from the side, if it was brittle and you applied pressure, it may actually shatter, and that would be very bad. The other thing that can happen as well, of course, is that the block of material is rotating at very, very high speeds. And if it's asymmetrical in any way, that can cause vibration. And again, that could cause the material to shatter. So basically, you usually find lathe materials are things like woods, plastics, and certain metals. You probably wouldn't want to put a block of glass in there unless it was very special glass that could take that kind of those kinds of forces. And as I said, because of the physical process in action here, the rotation and the cutting into the surface, the product of a lathe is always a cylindrical object of some kind. So lathes are used to produce the legs of wooden tables, as an example, or the axles of various wheels, or the axle of, say, a motor, for instance, or the axle of a train, or the axle of the wheels of a car, and so on and so forth. So, anyway, enough of the real world lathe. How does lathing work in 3ds Max? Well, unlike the extrude modifier, we can choose which axis of the shape along which the rotation can take place, i.e., are we going to rotate around the x-axis, the y-axis, or the z-axis? We can also choose how many degrees the shape should be swept through doing the lathe action. This is actually quite similar in a way to the extrude, but generally for a lathe you'd want 360 degrees. It doesn't actually have to be so. A typical lathe sweep would be through 360 degrees because what you're aiming for is a closed surface. And generally, because it's mimicking a real lathe, you'd want it to look like a cylinder at the end. And if you didn't go through a sweep of 360 degrees, you wouldn't get a surface that actually looks like a cylinder. It would look like a cylinder with a segment cut out of it. So good examples of usage of a lathe are an axle in a car, an axle in an engine, a wine glass, a metal washer, tires of a car, anything which is basically cylindrical in nature. And also, as I said, you can also create objects which are not complete cylindrical 360-degree sweeps. So it has some flexibility in that respect as well. And if you don't do a full 360-degree sweep, as I said, you can end up with basically what looks like a segment being cut out of the object. And that actually can be used for doing, those kind of technical illustrations where you have a segment cut out of, let's say, part of a machinery. So it can be used in that respect. Or, as I said, it can be used in lots of different manners. But basically, the options there. You can rotate around as far as you want. So anyway, that's enough talking about the theory of it. Let's actually have a look at it in practice. Okay, so let's start off with a very simple example. Let's say we wanted to create a wedding ring. This is a classic example of how you could use a lathe. Obviously, you could use a torus and deform it, but maybe your wedding ring has a very particular profile to it. So what we could do is let's say we could get a circle, and we could create a shape like this. And then I'm going to right click, convert to editable spline. And I'm just going to go in and edit this. I'm going to pull this in here to make it into a bit more of an ellipse. I'm just going to put this in here as well. Now I'm going to push this in even further, so it's actually quite flat at this point. And we'll use this as the profile for our ring. Now, the lathe will take place along this axis here, this pivot point. So what we want to do is, we know that if we were to sweep that around that point, this would actually it wouldn't create a ring anyway. So let's just move the pivot point to here. And now we can actually sweep it around this point, and that will create a ring. You can have a look at the diameter here and actually be quite chunky, but let's just show you what that looks like when we actually do a lathe with it. So let's go down here into the modifiers, lathe, and there we go. Just by chance, it's actually worked out and it's actually on the perfect axis. But if we wanted to, we could go on the x-axis. Nope, not good. The z-axis. Nope, not good. The y-axis. Perfect. So let's just turn on wireframe so we can see the surface more clearly, and then we'll get an idea of how this works. As I said, it's quite easy to think of, really. It's just like an extrusion, but instead of being in a straight line, it's actually a rotation around the pivot point of the object here. So we have a number of segments, so we can, let's say we put that down to 3. I think you get the basic idea. Just puts in more segments as we increase the value. I find that when you're working with cylindrical objects, you really want segments to be between, say, 24 and 32. Generally, I go straight to 32 because that gives us a good approximation. If it's a large object and it's going to be close to the camera, then you want to probably go higher than that, as you can see, to get a nice shape. You can actually go in afterwards and change the axis, as we covered in an earlier chapter, as you saw. Or you can actually do it at the beginning by moving the pivot point. Or you can do it after the fact by going in and moving the geometry around. So as we saw earlier, we'll put this lathe modifier back on here. And let's say we think this ring is too thick. It is actually quite thick and chunky, isn't it, for a wedding ring? Looks more like a tire. So what we do now is we go down to the editable spline, show end result. We use the procedural nature of Max, so we can do it interactively. Just drag that till we think it's the right kind of size. Now it looks a little bit finer. I would say it's maybe a little bit too thick still. So what we could do is we could actually scale the vertices. We'll use a single point in the middle there. I'm just going to scale it on this axis here. So the ring's a little bit thinner. Looks a bit more like a kind of wedding ring. And we'll just pull the vertices out a little bit further. So now we've got the right kind of shape now for a wedding ring, as you can see. A very simple example. Let's say, though, we didn't want it to be a wedding ring. Let's say we wanted it to be a mechanical part in an engine, some kind of bracket or gasket or something like that. So what we could do is we could go down, we could just edit this shape, and let's add some grooves into it. So I'm just going to go into sub-object mode, refine, and let's say we add a refinement there, and there, there, and there. And I'm just going to put in some points here and here, here and here. And now I'm just going to go in and grab these segments and move these in like this. And now, if you look at the resulting surface, it's now kind of more sort of mechanical looking thing, as you can see. And also you can imagine that being maybe the tire of a car or something like that. If you put lots of these little crenellations in here, then you can create the tread on a tire. So pretty cool, as you can see. Let's say we wanted to create an axle. Well, let's create another spline to do this. Let's just click off here, go to the top viewport. As I said, I prefer to generally create things in the top viewport. It makes it easier to just stick to 2 dimensions. So let's say we're going to create some kind of axle. So let's just keep it linear for now. We'll just click here. We'll create an end to the axle, where let's say we wanted to fit into something. So we'll just create a little center point there. And then let's say we want this to be like this. This here. And then we'll go down here. And we'll create a kind of square end here. So what you could do is you could kind of do that, and then you could get the pivot point, and you could just snap it using the snap tool down here, just the type in, snap it to 0 on X, so you know it's in the center of the world. And now we could just get the modifier from here, drop it on here, and as you can see, it's, let's see what we do if we change these. Yeah, we've got the right axis. The reason why it's done that is it's inherited the axis from this modifier here. So because we dragged it from here to here. So let's actually just get rid of that. Put a fresh modifier on, as it were. Let's just go here. Say lathe, LLL, lathe. There we go. Just picked up the pivot point from our object. So as you can see now, we've got this kind of axis, this axle kind of thing. If we don't like it, it's very easy to go in and edit it after the fact. We can just go into the top view, and we can either change the axis point, which we wouldn't want to do, because if we, let me just show you this in 3D. If we move the axis, it's going to make the object look like it's hollow. You can see a hole in the end here. So we want to keep that the way it is. But we can just go down here and edit the line itself. Show end result. Let's say we want to make this thinner here. Just pull in these vertices. And let's say this is a little crude, which it actually is. We could put some bevels on here very easily. Just refine this. This is the great joy of working with splines, is that you can just go in afterwards and refine things and make it a little bit better if you think it's a little bit crude. So we can just move this up here, grab these, move these down, move this in a bit. It's not quite the same kind of dimension as you have over here. And then we can just select all of these, right click, change to Bezier corner, and then we could leave them as corners if we wanted to, and we'd end up with this as the result, as you can see. But let's say we wanted this to be a little bit more curvy, so we can go in here. As you can see it update in real time. Pretty cool, eh? And the same here. Let's say we want that to be quite a bit more of a curve, so we can just edit that there as well. Same here, and the same here. Now, at the moment, it's got, if we look at the interpolation type, you can see it's using 6 steps, and it's optimizing. So we get less polygons in these areas. We just get one strip of polygons going along here. But if we wanted to, we could actually turn off optimization, and we'd have 6 steps between every vertex in our spline, as you can see. But obviously it's quite wasteful. We end up with all these segments here and all these segments here as well. So you probably want to have optimize turned on in most circumstances to keep the polygon count nice and low. Another classic example of the lathe tool in action is the wine glass. Let's say you can have wine glass shape. That's very easy to make. I won't bother creating a work of art here, but let's just very quickly knock up something. It may not be a wine glass, but let's go for something like a goblet or something like that. So we've got the base of the wine glass, so the bottom of the wine glass is here. Let's say we've got here. Then we create the bowl. There's the lip, interior surface here. You can see I've gone for very few control points. And as I said, this is something I tend to do. I try and keep it as low as possible. Let's go for smooth. And then let's go for Bezier. We got all these nice smooth points now. And it's just a case of now editing this into a shape you think is a bit more attractive. Let's say we don't like this, so I'll just hold on Shift to break this. Stop getting this excessively large sort of curve here. So there we go. Just make this a bit more linear. We've got the base there, here. You can see this kind of needs to be pulled down here. To make the inside of the glass kind of flat at that point, we'll do that. We'll just move this up here a little bit, in here like this. We'll do the same modification to this in a moment. We want to keep the glass to be nice and thin. We just want to create more curvature here. There we go. We got this funny looking lip here, so let's just modify that. Holding down Shift to break the handles apart so we can actually do this. There we go. It's quite nice. And now we actually the stem is quite large there, isn't it? Do that. Let's make this a little bit smaller. And then move this up somewhat just to make it a little bit more realistically proportioned. And then what we can do is we can just put a lathe modifier on there. Lathe. You can see the pivot point was in the wrong place, but we can always edit it after the fact. Just grab that. Move it to the center here. We are. Or we could just snap it using that. And now, if we have a look at this in 3D, we've got a reasonable approximation of a wine glass. Let's just rotate that around a bit, turn on snaps here, so make sure it, look, we were just 5 degrees off there, having it square. And we'll just put it on the home grid. Not bad, eh? I think it's actually inside out though, that's the only problem. So we know how to fix that. We just need to go down here, change the direction of the spline. Start point is here at the moment. We need to make it this one. Make first. Look at the shape. There we are. No, it's the actual right way around. It has a solid shape to it. In this case, obviously the number of steps in the wine glass are very important. If we turn on end result, just put this down very low. That's it with one step. 1, 2, 3, 4, 5, 6. So we get up to about 10. Again, a pretty good approximation. The other thing is the lathe itself. How many steps is it using? We can see at the moment it's using 100 segments. We can actually change that to be as many segments as we need to actually produce the nice shape. Again, when you're working with cylindrical objects, 32 is a pretty good starting point, I find. But if you're going to see a close-up, you may want to go higher. Pretty cool. So we now have an axle, a wine glass, and now, well, it was a wedding ring, but now some kind of mechanical ring. Let's finish off by looking at some of the options of the tool. How many degrees? Let's just change that. So we can change it so it doesn't sweep through the full 360 degrees. So we can create a partial lathe, as you can see here. When you do so, the cap start and cap end tick boxes come into play. Obviously, they don't really make much sense if it's 360 degrees. You can't lathe through anything more than 360 degrees. Once it reaches 360, these aren't used anymore, and it forms a closed surface. That is, of course, if the splines that make up the original shape are closed. You have this option here, which is weld core. The core is this vertex here. Basically, that means that if you have a vertex which should be coincident with itself, it can either weld it or it doesn't have to weld it. So, you know, basically the option is there. If you have a surface which has the wrong direction, as we saw earlier, let's say we had this, and this is a closed spline, so it doesn't actually make much sense with this one, but this one is open. So let's say we go down here, we change it so that it's the wrong way around. So I'll just select this point here, make it the first, and now you can see it's inside out. Well, you can just use this option here, flip normals. So now you've got yourself back to where you need to be. So there you go. You can choose how much of a full lathe it is by choosing your degree. As you can see in this case, it's not able to actually cap the surfaces. So you've got to be aware of that. It needs to be a closed surface. As you saw with this ring here, you can actually do it with that, but you can't actually do it with this surface. You can then weld the core, the center point here in the middle. You can flip the normals if your surface direction is wrong. When you have less than 360 degrees as the lathe, you can then choose whether the two end points of the lathe are capped or not. We've got the same options as we saw in the extrude tool. We've got morph or grid. Check those out in the online help for more verbose explanation of how those work. As I said, most of the time when you're working with extrusions or lofts or lathes, you're really not going to be morphing them. So really either of those options work really. Grid if you're going to deform it massively after the fact. Morph is the default option. Then you have the direction of the lathe. There's always one correct direction, and as you can see, there's always two which are incorrect. You just have to work out which one it is for your particular object. In this case, it's Y. With the tools below, you can choose to change the alignment of the shape to the axis. You can choose min. Let me just show you here. It's quite difficult to see this. So let me just turn off modifier for a second. So you can choose min, center, max. You can experiment around with those options there just to see which of those give you the kind of result that you expect. In most cases, I don't actually fiddle around with those at all. I just use the direction and just choose the direction from here. And I find that gives you the result that you need. So let me just show you those in action. Minimum, center, maximum. Basically, you can use it if you needed to. But as I said, generally XYZ is all that you really need. Then you've got the output. The default is mesh. It can be a patch if you want it to be, and it can be a NURB surface if you want it to be also. The option is there. Generally, I would obviously stick with mesh. And as we saw with the extrude, we've got the option to generate mapping coordinates or not. Do you want to generate material IDs? That would mean that you would have different material IDs on the end surfaces here. Also, you can use the material IDs which you've put into the segments of the underlying spline, which is pretty cool. So using that, you could, let me see if we have, no, we don't actually have a material. So let me just create one very quickly. There we go. Just apply it to this object here. And now if I go down, there you are, you can see these have got different material IDs. But if you say use shapes IDs, just as with the extrude, you can go down here and you can select these IDs. And by default, if we select all of the segments, we can say that they're all 1. Yeah. And we can say this one is 2. And we could say that this one is 3. As you see. And this would then apply a different material. Let's say it could be a different metal. It could be gold or platinum or steel, just to those areas of the model. So again, a very powerful tool, very easy to use, very flexible, and it's one of the key technical mechanical modeling tools in 3ds Max, as you can imagine. Whenever you want to create any kind of mechanical objects, then you probably want to have a look at the lathe tool and the extrude tool. So what we're going to do now is we're going to move on and we're going to look at the loft tool. And I can kind of characterize it as being a sort of extrude tool on steroids. And you could even use it to do the kind of things that we've seen here with lathe. It's very, very flexible, very powerful. We're going to look at that in 3 chapters, so we're going to cover that very clearly and very concisely. So let's move on now and have a look at the loft tool.